Hello and welcome to our lesson 9.3, graphing quadratic functions. At the end of the lesson you should be able to say that you can graph quadratic functions in standard form. Again, standard is ax squared plus bx plus c. We've got to know how to find the a, b, and c here. Our steps to graphing, there's 7. First we're going to rewrite in standard form if needed. We need to find the a, b, and c correctly, and that has to be in standard form, descending from x squared to x to the constant. Find and draw the axis of symmetry. I just abbreviated AOS. It comes up a fair amount in the lesson. Then we want to find the vertex. We call that HK. Then we find a point 1 to the right. We add 1 to the x coordinate of our vertex, and we'll plot that. We'll also go 2 to the right of the vertex, plot it, and then reflect the 3 points that we've got across the axis of symmetry. And at the end, we'll connect the dots with a smooth curve. Alright, so here is our first problem. There's a lot of work to do. First I want to verify, is it in standard form? It is. So I start off in standard form, and then from standard form I can make some predictions here. I can decide, since a is positive, this parabola will open up. Since it opens up, the vertex on the bottom, we have a minimum. And then as for all quadratics, all reals will be the domain. We can put any values in. Alright, so if we now take our axis of to find our axis of symmetry, we plug in negative 6, b was a negative 6, over 2 times 3. We get negative makes it positive. 6 over 6 is 1. And now we have our h. And so now we can graph the axis of symmetry at x equals 1. Alright, and we have our h now is 1. If we plug in our h, we can find k. So 3 times 1 squared minus 6 times 1 plus 1. We get 1 squared is just 1, so we get 3 minus 6 plus 1. 3 plus 1 is 4. Take away the 2 equals a negative 2. So our vertex is 1, negative 2. Alright, now we want to add 1 to our Alright, and now we want to add 1 to our x coordinate of our vertex. 1 plus 1 is 2. We plug in 2 then. 3 times 2 squared minus 6 times 2 plus 1. 2 squared is 4. 4 times 3 we get 12. Minus 6 times 2 is 12. Plus 1. So that reduces to a 1. 2 points to the right. We add 2 to 1. We get 3. Plugging in 3 we get 3 times 3 squared minus 6 times 3 plus 1. 3 squared is 27. Sorry, 3 squared is 9. 9 times 3 is 27. Minus 18 plus 1. 27 and 1 is 28. Take away 18, we get 10. So we have some points here we can plot. I'll use blue for that. 1, negative 2. So as we would expect, right on the axis of symmetry. 2, 1, and then 3, 10. Scale is up to 10. Okay, so we're done with the first 5 steps. Now we're going to reflect across. And if we look here, the point 2, 1 reflected across will be, instead of 1 bigger, will be 1 smaller for x, but the same y coordinate. And likewise, 3, 10, same y coordinate, but instead of 1 more than the 2, it's going to be 1 less than the 0. That'll be a negative 1. That'll become obvious from the graph. If I reflect over here, this dot goes to 0, 1, and you see that's what we predicted. Likewise, go 1 more, it's negative 1, and still the 10, negative 1, 10. And now I'm going to try to connect these dots in a smooth curve. And let's see how we did in our predictions here. We expected it to open up. It does. We did expect the minimum since it opened up. That minimum is -2. The domain, all reals. And now the range, it's going to be values that are no smaller than -2. So we'll say y is greater than or equal to -2. Great. In this problem, once you get started, verify it's in standard form, make some predictions, and then go through the calculations. We'll get started. We'll do it in phases here. So first, it's not in standard form. Go ahead and rewrite it in standard form down in this area for step 1. Okay, hopefully you got x squared plus 2x plus 3. For predictions, see what you can gather from this information. Hit pause. Okay, since a is positive again, we expect this parabola to open up. It has a minimum at the bottom of the curve. That's the vertex, and again the domain, all reals. All right. So from here, let's find our axis of symmetry. -2. It's a +2. So opposite of that is -2 over 2 times 1. That's -2 over 2, -1. So our h is -1. Let's go ahead and sketch our axis of symmetry here. And then plugging in -1, we get -1 squared plus 2 times -1 plus 3. -1 squared makes it a +1 minus 2 plus 3. 1 and 3 is 4. Take away 2. We get a 2. -1, 2. Adding 1 to -1 comes up to 0. Plugging in 0, we get 0 squared plus 2 times 0, and then plus 3. That answer is 3, and what you find is every time you find the y-intercept, plugging in 0 just makes all the terms with x's go away, and all we'll have is the constant or the c value. Finally here on our step 5, we add 1 to 0, we get a 1. 1 squared plus 2 times 1 plus 3 is 1 plus 2 plus 3, and that's 6. All right, plotting these points, -1, 2 again lands on our axis of symmetry, 0, 3, and 1, 6. Now step 6 would be to reflect across. If we go, instead of 1 bigger than -1, if we go 1 smaller, we get -2, but the same y-coordinate. And likewise, 1 smaller than -2 will be -3, but the same y-coordinate. And by looking at it visually here, we see that this point has to reflect over to here, and if we check, it's -1, 2, up 3. Likewise, this dot will go over to here. That's -3, 1, 2, 3, 4, 5, 6, and that's what we predicted. Try to make a smooth curve here. Didn't do a great job, but I should be able to move this. Alright. I'm going to say that's a parabola. Alright, so let's see what we get for information, see if it matches up. It does open up. It has a minimum at y equals 2. The domain again is all reals. And the range, all values have to be 2 or larger. We'll call that y greater than or equal to 2. Our last problem here, why don't you try getting started and hit pause throughout as I explain and see how your numbers work out, and after this we'll be ready for the on your own. So let's start with finding out if this is in standard form, make some predictions, and then get to work. So go ahead and hit pause, and then throughout you can hit pause when you want to do your own work. Okay, in this case I have to subtract the 8 over the 8x, and from this information then we can guess that this thing with an A that's negative should open down, making a maximum at the vertex and the domain all reals. So if I plug in my negative 8 over 2 times negative 2, I get 8 over negative 4, which is negative 2. H is negative 2. Plugging in negative 2, I get negative 2 times negative 2 squared minus 8 times negative 2 plus 3. Negative 2 squared is a 4. 4 times negative 2 is negative 8. Plus minus negative 16, so plus 16 plus 3. And this will all add up to 19 minus 8 is 11. So I get a vertex of negative 2, 11. Now I forgot to put my axis of symmetry. Let me go back and get that. Axis of symmetry should be at x equals negative 2. And our vertex, negative 2, 11. Okay, and 11 is probably up here somewhere. Now we'll add 1 to negative 2, we get negative 1. Plugging in negative 1, we get negative 2 times negative 1 squared minus 8 times negative 1 plus 3. We get negative 2 plus, it's a negative 1, so plus 8 plus 3. 8 minus 2 is 6. 6 plus 3 is 9. So we get negative 1, 9. And adding 1 to negative 1, we get 0. Plugging in 0 is easy. The x terms go away, and all I'll get is my 3. So I can just, without calculating, get my y-intercept. We'll plot these points. Maybe this time I'll take a guess first. The 9 has to repeat, the 3 has to repeat, and instead of going 1 bigger than negative 2, I'm going to go 1 smaller. Instead of 2 bigger than negative 2, I'm going to go 2 smaller. So these points should be where I reflect. I'm going to start off with my vertex, negative 2, 11. Starting off with my vertex, I start at negative 2, 11. Then I go negative 1, 9. 10, 9 is right here. And then 0, 3. 1, 2, 3. So this one has a fair amount of stretch to it. Reflecting over, I get 1, 2, negative 3, 9. Very good. And then negative 4, 3 is going to be here. Trying to make a smooth curve gives me a graph like this. Now let's see here. This is a graph that does open down. It has a max because of that up here at 11 at the top of the vertex. So y equals 11. The domain again is all reals, and the range has to be less than or equal to RK. All right, try the on your own. We'll see you in class.